So we have a synthesis question here. Very common questions on the organic papers. Synthesis is a very important part of it. It's something that is going to take some time to learn, making sure you're learning all your reagents and conditions, all the conversions. You've got to try your best, commit them to memory, and then obviously be able to apply them in the scenarios you've been given here. And this one should be fairly straightforward because you're starting with just a normal benzene ring. They're not trying to trick you in any way by putting extra groups on there. Just a benzene ring, and you've got to follow that process through to get to this molecule here. So we can see we have an alkene present there. All right, we have an intermediate product here. We've got a ketone present here. So we will first of all think about how am I going to get my benzene ring to now suddenly have this branch stuck to it with a ketone on there. So the first box, you're going to be drawing the molecule that will react with your benzene and state the conditions that will produce this compound. All right, and from there then you've got to fill in the gap. How will I get from this ketone to something else to an alkene? So you've got a two-step process going on there. And at the bottom, you've got a polymer to form. So let's work through this one. So benzene, first of all, if I'm trying to put another carbon chain onto my benzene ring, this is a Friedel-Crafts reaction. Okay, so in this case, it's acylation because I'm looking to put this double bond O on there. So I need to have an acylation reaction, which means my compound I'm going to react the benzene with has got to be an acyl chloride. So my chain here has got 3 carbons with a double bond O. So I must need propanoyl chloride, 3 carbons with the double bond O and Cl on the end. So I'll keep it in skeletal formula. Double bond O, Cl, so that's the first carbon. 1, 2, 3. Propanoyl chloride. If you're not sure about it, then draw it in displayed formula if you're worried about getting the right number of carbons in your compounds. It doesn't specify which formula to use, which type of drawing to use. So if I draw this in displayed formula, what have I got? Carbon there, Cl, 1, 2, CH2, CH3. It's propanoyl chloride. Either one of those then is what's going to allow this to stick on. Now, in any acylation reaction, any Friedel-Crafts reaction, I need a catalyst. The catalyst contains the same halogen that's present here. So it's an acyl chloride, so the catalyst will always contain chlorine, and you need specifically aluminium chloride, AlCl3. Okay, so the application of this question here is understanding that you've got an acylation reaction. From once you've clicked that, then you've just got to remember, well, what do I need to do? What do I need to react to make this happen? And that's where the difficulty comes from. You've got to spot, first of all, what is it that's going on, what reactions are taking place, and then think back and try and picture those synthesis maps, those routes, those things you learn to remember what am I going to react with my benzene to get the right answer. So that's the first section done. So now you've got to think in a bigger term. How do I now get from this ketone through to something to an alkene? So you've always got to think backwards. In what ways can I make an alkene? What can be turned into an alkene? Okay, and then think from there. Well, from there, can I get that from my ketone? Okay. Now I know that I can make an alkene from an alcohol. An alcohol can be dehydrated. An elimination reaction takes place to form my alkene. And I also know then that I can reduce a ketone into an alcohol. So therefore, that's my process. This, therefore, has got to be an alcohol. So if I follow the process through, keep the benzene ring. Okay, so 1, 2, 3. So if I reduce my ketone to a secondary alcohol, that secondary alcohol then can be dehydrated and elimination can take place to convert that into an alkene. So that's my midway chemical, my midway product. How would I reduce a ketone to a secondary alcohol? Well, that is done by sodium borohydride. Oops, I missed the B out. NaBH4, sodium borohydride, or sodium tetrahydroborate. It's got a whole variety of different names. Just remember NaBH4. So that's the middle bit finished. And then lastly, how do I then dehydrate an alcohol to an alkene? Try and picture those synthesis maps, picture and remember your reactions. That is dehydration. That needs an acid catalyst. Okay, you could specify sulfuric acid, concentrated sulfuric acid. You could state just H+. You could say phosphoric acid. As long as it's mineral acid, not an organic acid, then that will do. Okay, but acid catalyst is perfectly acceptable for that. So we've got that going across there. And lastly, I'm looking to form a polymer from this reaction. So if I've got an alkene here, I can make an addition polymer by breaking the double bond and making sticky ends on either side. So if I break the double bond, I'm left with a single bond. Okay, I've got a methyl group going up there. So if I do a carbon there, CH3, that is this bit. The bottom will be a hydrogen. Up here, there'll be a hydrogen. So if I do another C there, and a hydrogen there, and then down here, I've got my benzene ring. And then draw your sticky ends, and then your brackets. If you want to finish it off, put an end there as well. There's your polymer. And the last bit of this question, polymer I cannot be disposed of in landfill sites as it's not biodegradable. Suggest one way of processing waste polymer I other than landfill and recycling. So this is going back to year 1 work where you learnt all about your environmental problems with plastics, a big thing in the news at the minute, obviously. So I hope you're all trying to reduce your plastic waste. So how can we do this then? Well, polymers can then be used other than landfill and recycling as organic feedstock, so they can be turned back into other different things for other reactions, or you could burn it. You can burn them to produce energy. Okay, so just saying burning it isn't enough, or combusting it isn't enough. You want to go for the combustion route. Why are you combusting it? So you're burning it, you're combusting it for energy purposes, to produce energy. Okay, so that's probably your best answer there. So combustion to produce energy would be one way of processing it. Or, like I say, you could say it's an organic feedstock, or to produce other plastics.